This is part 1 of 2 of trig equations. So this corresponds to section 7.3 in our book called Trig Equations here. Just to remind you of a couple basic things that I'm going to be using that I'm assuming you already are familiar with is all students take calculus. So all 6 trig functions are positive in quadrant 1. Only sine is positive in quadrant 2. Only cosine is positive in quadrant 4, and only tangent is positive in quadrant 3. Now, if sine is positive in quadrant 2, so is cosecant. So whenever you flip a fraction over, it remains positive there. And if cosine is positive in quadrant 4, so is secant, all right, because that's the reflectical of cosine. And if tangent is positive in quadrant 3, so is cotangent. And then, of course, all 6 trig functions are positive in quadrant 1. Now, another thing, you may have heard me refer to this instead of the unit circle, it's really the unit triangle. There are really only 2 different triangles in this whole diagram here. We have a 30, 60, 90, okay, and we have a 45, 45, 90. So this is a 45, 45, 90 triangle. You may say, what about this? Well, this is really the same triangle as the first one here. It's just instead of the 30-degree angle as the reference angle, there is a 60-degree angle as the reference angle, and that puts the 30-degree angle up there. So really, even though you're seeing 3 different triangles here, the 2 skinny ones are the same one, and then the equilateral triangle at 45 degrees is the same triangle. And then, of course, this is also a 45, 45, 90 triangle. This is a 45, 45, 90 triangle. So it's the same triangle over and over and again. So, so that diagram that I just showed you, I'm going to be using that to solve all of these equations. Even if you do use your calculator to solve these, first of all, make sure you're in the right mode. This is referring to radians. I always work in degrees, so I would just change your calculator to degree mode and then convert all your answers at the very end into radians. That's what I recommend. I'm very comfortable with degrees. I can visualize it. Radians I'm not that comfortable with. So even if you do use a calculator, your calculator will only give you one of the solutions. You're the one that's going to have to look at the chart here and figure out what other quadrants these solutions can come in. So it's asking you to solve for all angles between 0 degrees and this is 360. So you need to find all the solutions in one trip around the unit circle. All right? So there could be 1, 2, 3, or 4 different solutions for all of these. Now, what you need to do is you need to treat the trig function like a variable. How about the letter y? Okay? So if we do that, this is no different than solving 4y squared minus 3 equals 0. Now to solve for y, you would do 3 steps. You would add 3, divide by 4, and then square root both sides. So that's what I'm going to do here. I'm going to use c for cosine. I'm going to add 3, divide by 4, square root both sides. Now do not forget the plus minus. A lot of you are getting incorrect solutions because you're forgetting the plus minus. And this turns out to be root 3 over 2. So that root 3 should ring a bell because root 3 is all over that unit triangle paper. So let's first take care of the positive solutions. So root 3 over 2, positive cosine. Root 3 over 2, positive cosine. Now cosine is the x value, okay? So root 3 over 2, which is what we got here, positive. Cosine is positive in quadrants 1 and in quadrants 4. So there's our root 3 over 2 in the x position. And remember, x is cosine. So for the very positive solution, we have that one, which is 30 degrees. And then we have this guy here, which is also 30 degrees. So the reference angle is 30 degrees. However, the first solution is 30 degrees, which is pi over 6. Okay? And then you start over from 0 again, and you have to swing around the whole thing to get to this hypotenuse here. Even though the reference angle is 30 degrees, the angle measure is 330, or 11 pi over 6. Okay, so for the positive scenario, we have pi over 6 and 11 pi over 6. It's not very dark. Let me choose a darker one there. All right, I'm leaving a space here because I'm going to put these in numerical order from smallest to greatest, just for etiquette's sake. So cosine is positive in 2 quadrants. We have 2 solutions. Now cosine is negative in 2 quadrants as well. So cosine, I have to find the negative root 3 over 2, which is here, the negative root 3 over 2, and once again, I'm looking for the x value because cosine and x are related to each other. Cosine, sine, x, y, alphabetical order. So in this case, we also have a 30, 60, 90 triangle in the second quadrant, and another 30, 60, 90 triangle in this quadrant. So here's the first one, here's the second one. 5 pi over 6 is one solution, and 7 pi over 6 is the other. So that'll be 5 pi over 6, and 7 pi over 6. I'm going to squeeze that in there. And then the fourth solution would be 11 pi over 6. So cosine is positive in 2 quadrants, 2 solutions. Cosine's negative in 2 quadrants, 2 more solutions. Root 3 over 2, cosine is the x value, and so I only look at the x values here. Now I'm talking really, really fast, so bear with me here, okay? So that is the first solution. Now I've muddied the waters here. Let me clear this up. And we'll do the second example for this particular round here. So what about if you have 2 different trig functions? We have cosine squared here. Now once again, treat this like a factoring problem. Now if I factor out a y, which is the greatest common factor, what I'm left with is 2y plus 1. All right, so if you get a squared piece and a non-squared piece, you just factor out like a greatest common factor. So think of this as an algebraic exercise. Now, we factor out the y, we're left with this. So we have something times something equals 0, which means that the first something has to be 0, or the second something has to be 0. Now remember, we let y equals cosine, so I substitute again. Y equals cosine. Y equals cosine, so let us go back and substitute. So cosine is equal to 0, and then cosine, I have to solve for cosine here, so I'm going to subtract 1 and divide by 2, so I get negative 1/2. All right, this is not being squared, so I don't square root both sides. So since cosine is negative in 2 quadrants, I'm going to have 2 solutions. Cosine is the x value. I'm going to go hunting for negative 1/2 in quadrants 3 and 4, okay? Because cosine's negative in quadrants 2 and 3. So let's go hunting for negative 1/2 in the x position. Negative 1/2, negative 1/2. So this is a 30, 60, 90 triangle. So that is, in this case, the reference angle is 60. And then this is the same triangle. This reference angle is 60. So the reference angle is 60, but the angle measure starting from 0, you have to swing over 120 degrees to get there, or 2 pi over 3. And the other one, to get to that, we have to start from 0 again, and we have to swing over all the way to here. In that case, 240 degrees, or 4 pi over 3. So 2 pi over 3, 4 pi over 3. So this guy here is going to give us 2 pi over 3, 2 pi over 3, and 4 pi over 3. Quadrant, that is quadrant 2 and quadrant 3 solutions And once again, even though the reference angle is 60, it's a 30, 60, 90 triangle, this angle measure is 120 or 2 pi over 3. Even though this is 60 degrees, this angle here is 240, starting from 0, which is 4 pi over 3. All right. So that concludes part 1. And I started with some medium examples. These are not easy. These are challenging. This assignment is challenging, I do admit. So part 2 coming up in a few minutes. Hey kids, the last video that I just made on part 1 of trig equations, I stopped it about 30 seconds too short. I apologize. This thing here gives us two solutions, the 2 pi over 3 and the 4 pi over 3. But there's another little part here. It says that cosines equal to 0 here. So what we're going to do is we're going to go back to the unit circle, the unit triangle, and we're going to see where the x value is equal to 0. The x value is equal to 0 at the North Pole, and x is equal to 0 at the South Pole. So we're going to look here. Cosine is 0 at the top and at the bottom. That is pi over 2 and 3 pi over 2. So here, theta is going to be pi over 2, which is the North Pole, and 3 pi over 2, which is the South Pole. So sorry, this video is the very ending of the first video. I apologize.